Hey guys, so if you're coming from this other video, welcome back, and if this is the first video you're seeing, today we're going to be going over single and multi-step equations and how we're going to go about solving them. So this will be a little more in-depth explanation as to how we're going to go about this and how to follow these simple steps. So starting off here, we're going to be looking at single step equations. So when I say single step, I just mean we're going to be looking at this equation right here, 4x equals 8, and it'll only take you one step to solve for x. So the end goal is always solving for that variable that's in your equation. So if I look at this, I know that I want to isolate x, and to do so, I'm going to take this over 4. So I'm dividing by 4 because to get rid of that 4, if I divide a whole 4 by 4, it will equal 1, and that would leave me with just 1x. And the important thing to know that when you're solving these equations is that what you do to one side, you have to do to the other side. So I'm also going to be dividing 8 by 4, and you can do mental math, plug that into your calculator, and you'll get x equals 2. So that's one type of single-step equation. The other type here is addition or subtraction instead of this multiplication or division. So here, again, I want to isolate x. So if I'm looking at this equation, I see that there's a negative 5 attached to this x. So to get rid of the negative 5, I want to add 5 because negative 5 plus 5 equals 0. And that would bring your whole side of this equation to just equal x, technically plus 0, but since we know it's 0, you can just leave it at x. And then what you do to one side, you have to do to the other side. So I'm going to add 5 to this side, and I get x equals 8. So the important thing to note is just, again, what you do to one side, you are always doing to the other side. Now we're going to take a look at multi-step equations, and you'll see that they kind of build off of each other. So with multi-step equations, I'm going to write PEMDAS out just so you can see. But when you're solving for x here, you kind of want to do a reverse PEMDAS. So instead of your parentheses or exponents first, you're going to be doing your addition or subtraction. So if I'm looking at this, I know that I want to get x by itself. But before I can get x by itself, I know that I have to get 4x by itself. So in order to do that, I want to get rid of this 5 right here, or this negative 5. And by doing that, I know I can add 5. And what I do to one side, again, I must do to the other side. So I'm left with 4x equals 11 plus 5, which is 16. So now that I see this kind of looks like this single one up here. And I'm going to follow those same steps. So I want to get rid of this 4 attached to the x. So if I divide by 4, that's technically 1x. And again, what I do to one side, I'm doing to the other. So I'm dividing 16 by 4, and that would give you x equals 4. Let's look at another example. So again, it's that reverse PEMDAS sort of step. So I'm going to be starting with my addition or subtraction. So first, I know that I want to get rid of this 3x. I want to isolate the 3x, sorry. And by doing that, I see the positive 4, and I know that if I subtract 4 from that, meaning I would subtract 4 from both sides, that would give me 3x equals 6. And again, you can see this kind of goes along with this single step equation up here. So I want to isolate the x now. And to do that, if I have 3x, and if I divide that by 3, I have 1x. And what I do to one side, I have to do to the other. So x equals 2. So that's just a little step-by-step on how to solve single and multi-step equations. So if I take a look at these, this is just adding another step onto those multi-step equations. So this would be solving when you have variables on both sides. Typically, it'll be the same variable for this unit. So we're going to take a look at this. So when I'm looking at this and I see there's an x on this side and there's an x on this side, before I solve anything, I want the x's to be on the same side. So I don't want to have them on opposite sides of the equal sign because that'll just make it more difficult in the future. So if I'm looking at this, you can subtract 9x from both sides, or you can subtract 4x from both sides. Personally, I think it's easier to just go with the smaller number. So I'm going to subtract 4x from both sides. You aren't dividing yet just because you don't have that variable isolated to one side yet. So if that's the case, you are still doing addition and subtraction, just of making sure that you're combining your like terms. So I'm only doing the x's with the x's. So if I subtract 4x from this side, that leaves me with 0x and just 8. Subtract 4x from 9x, and I get 5x plus 3. Now looking back, this kind of looks like one of these multi-step equations again. So I'm going to do that reverse PEMDAS. It's not necessarily reverse, but I'm just doing it in backwards order. So I'm going to start with my addition and subtraction, and I want to get 5x by itself. So to do that, I know I can subtract 3 from positive 3, and that will give me 0. And what I do to one side, I'm doing to the other. So that equals 5, and I have just 5x on this side. Now looking at this, I want to isolate just the x. So to get rid of this 5 as the coefficient, I'm going to divide by 5. What I do to one side, I'm doing to the other. That equals 1, and you have x equals 1. All right, looking at this, it's another solving with variables on both sides. So my first step, I can go ahead and have you pause the video and see if you can work it on your own, or you can follow along as I solve it. Okay, so my first step, I can either subtract 12y from this side or subtract 5y from this side. I'm going to go ahead and do the smaller number and subtract 5y. And since I'm doing it to that side, I have to do it to the other side, making sure that it's constant with the like terms. So these two, that would equal 0, and I'm left with just 11 on this side. And then here, if I have 12y minus 5y, I'm left with 7y minus 3 equals 11. And now I see that I have my variable on one side, and I want to isolate that. So I'm going to go ahead and add 3 to both sides. I'm left with 7y equals 14. And then just like solving those multi-step equations, I'm going to be dividing. And this one here narrows down to a single step. And 7 over 7, that equals 1y. 14 over 7 is 2, and you have y equals 2. So hopefully you got that as your answer, and that means you're on the right track. So the final thing, you can go ahead and stop the video, or you can open up the homework practice problems that are linked in the website as well. And I'm going to work through the first 4 just so you guys have a better understanding and you can see it, and then go ahead and complete the rest of that homework. And there's an answer key linked with that as well. So we're going to just start off with these first 4 on your paper if you need a little more guidance. So right here, this is your first problem. You have 6r plus 7 equals 13 plus 7r. So this is one of those where you have your variables on both sides, and you want to isolate your variable, which is r. So my first step is I want to get r just on one side. I don't want to deal with it on both sides. So I'm looking at this, and I can subtract 6r from both sides. That will leave me with 0r over here, so just 7, and then 13, then 7r minus 6r would be just plus r. Now this is another one of those single step equations, so I see here that I have my r. I want to isolate this, so I want to get rid of the 13 on this side. So by doing minus 13 from the positive 13 attached, that will give me 0 plus r. And again, what we are doing on one side, we're doing to the next. You can plug this into your calculator, and you should get negative 6 equals r. Let me rewrite that so it's a little less weird looking, and r equals negative 6. Okay, you can go ahead and pause the video if you want to work through these on your own, or again, follow through with my steps. This is another one where variables are on both sides. This whole practice sheet will help you get really good at doing that. So I'm looking at this, and this is a little different because here we're subtracting, whereas all the other ones we've done before are adding, but that really shouldn't make too big of a difference because instead of subtracting your variable, you're just going to be adding it to cancel it out. So here I have my negative 4x. And to get rid of that, I'm going to add 4x to both sides. So again, this is just to ensure that I have my variable on one side before I proceed to anything else. So if I add 4x to negative 4x, I'm going to be left with just 13 on this side. Then 1, and if I have negative x plus 4x, I'm going to have positive 3x. Now I want to isolate my variable now that I have it on one side, and by doing minus 1 from the 1 here and minus 1 over here, because I'm doing the same thing on both sides, I'm going to get 12 equals 3x. Divide that by 3, divide that by 3, and I will get x equals 4. Okay, now for your third problem, same thing, but it looks a little different here because you see that there's multiple variables on this side. So here I'm going to go ahead, and the important thing to note here is that before you go on or do anything, I think it's helpful to combine your like terms. So if I have negative 7x minus 3x, you're looking at these coefficients. You have negative 7 and you have negative 3. If you add those together, you're going to get a total of negative 10x, and then this 2 just tags along. Okay. So now you're going to treat this like you did above, and I want to get my variable on one side. So I see this negative 10x, and I know if I add 10x to that, which means I have to add 10x over here, that will leave me with just 2 on this side, and then positive 2x minus 8. And then I know I want to isolate my variable on that side, so I'm going to add 8 to both sides. Running out of room here. I have 10 equals 2x. And then if I divide both sides by 2 to cancel out that 2 on top and leave me with just x, I'm going to get x equals 5. All right, so hopefully you didn't get too thrown off with the two variables on the same side, because you can just combine those like terms, and that should help you see that it's a pretty simple equation. It's just like the ones we've been doing. All right, so that's the case with this one. We have x minus 4x. So since these are like terms, that means you can combine them. So on this side, that'll just stay the same for now. And if I have x minus 4x, it's like taking 1x minus 4x. So 1 minus 4, and I will get negative 3x. Now I know I can add x to this side because I don't want my x's on both sides. I just want it over here. I can add x right here. I'm left with negative 8 equals negative 2x. And then this is the first time we're really seeing a negative come into play, but you would just treat it the same way, just making sure to note that they are negative when you're plugging it into your calculator or rewriting it, because it can be easy to forget to write those negatives. So if I do negative 8 divided by negative 2, I know that equals 4, and x equals 4 because this cancels out. All right, so that's it for this video. You can continue to work through those practice problems, and there's a key linked with it.